Okay, so in our previous class, we discussed about, we introduced year 6. We went over some year 6 features and we stopped at destructuring assignments, which we discussed about object destructuring and array destructuring. So today we will continue with default parameters, rest and spread operators. So first of all, we'll be looking default parameters. So what are default parameters actually? So we'll first of all look at the problem. So before ES6, JavaScript functions didn't have built-in default. So developers had to manually check for undefined parameters and assign default values. Okay, so let's see how this was done prior to ES6. So before ES6, okay, let's say function as an old way. So we take in parameters like name and age. So before ES6, you have to do something like name is equal to name, or let's say anonymous. And you do something like age is equal to age or 0. So if name is undefined, name should be equal to anonymous. And if age is undefined, age should be equal to 0. So actually this approach had issues. So first, false values, or 0, false, and empty string. You know, if name is equal to 0 or name is equal to false, then name will become anonymous. So that is actually an issue. And then verbose and repetitive code. So this actually is repetitive. We don't want to be doing this always, checking for name, checking for age, and all of that. And there's no clear indication of functions expected interface. So ES6 introduced default parameters. So it actually allows you to specify default values directly in the function signature. Parameters are only defaulted when they are undefined. There is no when there are other false values, which are actually undefined, not false values. So this, the benefits of ES6 introducing default parameters had to do with cleaner, more readable function signatures, self-documenting code, proper handling of false and undefined values. So the behaviors of default parameters are actually handy, and default parameters have some rules that we'll have to look at. So one of the rules is default values are evaluated at call time, not definition time. So when you do something like, okay, function, new way, and you see name is equal to anonymous, you see something like log name. So this is actually evaluated at call time, not definition time. When you call this function, the name here will be evaluated, not when you define it. That's the reason why when you call this function, okay, let's say we have name here, which is undefined. Then we'll come over here and say log something. Now we'll call this function new way. We'll run this code. Node, is it default params here? JS. Let's scroll up. Cannot find, okay, default params, just, oh, okay. No default params. Okay, so as you can see, this value is actually evaluated at runtime, not definition time. It's when we call this function, but that this is being evaluated. So as if the first line executed, something was logged on the console, and then the second line, which is the name, and the name here is actually undefined. That's the reason why we're seeing undefined here. Default expressions can reference previous parameters. That is the second rule. And the third rule here is parameters without default cannot reference later parameters without default. Rule number 4, undefined triggers default values, but null and other values don't. Undefined triggers default values, but null and other false values don't. So this name here is actually undefined, but by the time, let's say how can we do this? Maybe we assign this to, this actually is undefined. You can say it's equal to, maybe we should think of a proper way to demonstrate this, but this here is undefined. But when you say is equal to null, and then you come over here and run this function once more, now we have null because this is assigned to null. And null is actually, you are explicitly assigning a value of null. Even if it's nothing, you are assigning it to this name here. So when you execute this function, name will be logged as null because it is not undefined, it is defined and a value is assigned to it, even though it's not useful, but null is assigned to name. Okay, so let's actually look at advanced default patterns. So what we can do here is we can just come over here and let's say function, and let's take a greet function, and let's say greet old. This is the old way of doing it. And then we pass name and greeting. So inside this name, we see name is equal to name or guest. And greeting is equal to greeting or hello. And then we say return greeting, concatenate this with a comma. Then we'll concatenate it with name and an exclamation mark like this. So by the time we call this function, see log greet old, and then we pass in John, and we pass in hi as the greeting, the name of John and hi as a greeting. So if you run this code now, we have hi John. We have hi John. But what happens if we pass in, let's say this hi now, which is the name, let's say we pass in an empty string like this, and then we run this. We see, okay, hi guest. We see hi guest because, or consider an empty string as null. It is empty string is falsy, 0 is falsy, null is falsy, undefined is falsy, and false is falsy. According to how or this or operator evaluates 0, empty strings, null, undefined, and false as falsy values. So if you pass in an empty string, it will evaluate it as false and then default to guest. That's the reason why we're getting high guest. Okay, but what if you do something like, but this is actually ES6, not the old way. Now we have high exclamation mark because this is not actually falsy. This is an empty string. So this operator here checks for only undefined and null. You can do something like, but then there was nothing like this because this is actually ES6. So we have our OR operator here. Now, how can we, this problem was actually solved by, we can actually solve this problem by trying to look at the function and maybe trying to debug, or what we can do is, since ES6 was introduced, we can say, okay, const new way, then we pass in name is equal to guest, greeting is equal to hello, and then we return greeting, and then there's a comma, name, and then an exclamation mark. So this is ES6, and it's very, very straightforward. So we can just do this and then call this new, or greet new. Instead of new, we say greet new. Then we'll come over here and change this to greet new. And we'll run this once more. Then we have hi exclamation mark, because this knows, ES6 knows that an empty string is not false. It's not a false value. So you can see now hi exclamation mark instead of saying hi guest. So we can, if we omit this, if you do something like this, if you not use, or if you do something like undefined, and then you run this, you see hi guest. Or if you pass in null, and then you run it once more, you see hi null, because that is the reason why. That's the reason why we stated earlier of the rules. The rules here, which is the number, I guess I mentioned is at the number 4 rule. Undefined triggers default values, but null and other false values don't. So if you pass in 0 here, JavaScript will say hi is 0. If you pass in false, JavaScript, false, not false, actually false. And we run this once more, we have hi false. But by the time you pass undefined, you are letting me know that, okay, it should use the default value assigned to this parameter, which is guest, and now it will evaluate to hi guest. So that is actually sweet. That's basically about default parameters. We can go further and then show more examples, but because of time, we will just move over to rest and spread operators. Okay, so the fundamental concept behind the spread operator is a spread operator spreads, or it expands iterable elements, only elements that are iterable. So that is arrays, strings, and objects into individual elements. So think of it as unpacking a container and laying out its content actually. So if you want to spread, elements that are not iterable, you will get an error. It only spreads elements that are iterable. That is arrays, objects, and strings. So where can we where spread can be used? So we can use spread in function calls that spread array elements as individual arguments, or you can use as array literals. You create new arrays by spreading existing ones. That is, you don't want to mutate data. The object literals, you create new objects by spreading existing ones. And then destructuring, we combine with destructuring patterns. So the mental model behind the spread is imagine you have a box of items, actually. Then the spread operator takes the items out of the box and places them individually on a table. So you have an array. Let's take a look at an example quickly. Okay. So you have an array of let's say name is equal to John. So this is iterable actually, because you can say for const character of name, you say log character is, so node spread JS, and now we have JOHN. So this is iterable. We're iterating over this string and then logging each character. So here you can come over and say, okay, instead of logging this, we can say log name. And then we have JOHN like this. We're iterating over. We can even do something more, maybe log each character on a new line, but we'll just leave it like this. So as I mentioned about the mental model, imagine you having a box of items. So what this does, it will actually spread, the spread operator will take each item out of the box and then place them individually on the table. So this is the table we have, and then it's taking inside the string, it will remove J, place it on the table, remove O, place it on the table, remove H, place it on the table. So behind the scene, the time taken, or let's say the time taken to this O of N, because for each element, this will iterate 1, 2, 3, 4 times. So if you have 4 elements, this will iterate 4 times behind the scene. So the time taken to do this is actually let's not evaluate algorithms right now, but just trying to let you know this is running a loop behind the scene. That's what I want to say. It's actually running a loop behind the scene to do this. So if you do this and you nest an element in another one, you do this, that is O of N square. That is the time complexity will become O of N square, something like this. This is what I'm saying. Like this. But for this one, it's just this. Okay, the time complexity is just O of N for this one, because it's actually running a loop to do this. Okay, so that is the mental model behind the spread. And we've also talked about where we can use spread, function calls, array literals, object literals, and destructuring. So we earlier mentioned 2 things here. We mentioned rest and spread operators. So now that we've discussed about the spread, let's talk about the rest as well. So rest parameters collect multiple elements into an array. So it's the opposite of spread. You have to get this right. If not, it will confuse you. Rest is the opposite of spread. So instead of unpacking, it packs individual elements into a container. You know, the spread unpack a container, while the rest packs a container. Instead of removing element outside of a container, it puts those elements and then pack it in one container. So where can we use rest? So we can use rest in function parameters, array destructuring, and object destructuring. So the mental model behind rest is just like the mental model behind spread, but in opposite directions. So rest is like having a container that automatically collects loose items and packs them up. Instead of unpacking a container, it packs those items into a container. So it's the same syntax as this the spread, but then in opposite direction. So the spread, the main difference here, spread, expand, or unpack a box, or let's say an array, into individual elements. And then the rest collect or pack individual elements into a box. Let's say the box an array, object, or a string. Okay, so for rest, the example is almost the same thing, but then let's say we have const numbers 1 is equal to 1, 2, 3. Const numbers 2 is equal to 4, 5, and 6. So I actually want to merge. Const merged numbers is equal to, we'll just do something like this. And now if we log merged numbers, what we have on the console here is 1, 2, 3, 4, 5, and 6. So we've created a single array. So without this, if you want to merge this, you do something like, for let's iterator, let the iterator be k, which is equal to 0, and k is less than numbers 1 dot length. You say k plus plus, and inside of this, you see that's for each element in numbers 1, you see, or let's say numbers 2. Let's change this to 2. You see, we just want to merge, or we can do something like, we have merged numbers, and then after this we can join the two arrays and then get the length, and then instead of pushing into the second array, we can just create a new array, merged numbers, and then add all these elements, the first one, the second one. But this one, what I would do here is I would just say numbers 2 push numbers 1 push numbers 2 where that index is, where the iterator is. So when it starts, it will push 4 to the end of here. It will have 1, 2, 3, and 4. Again, second run, it will push 5. We have 1, 2, 3, 4, 5. And the last one, we have 1, 2, 3, 4, 5, and 6. It will push 6. Okay, but this is not the best way. I'm just showing you what's happening behind the scene. What's happening behind the scene is this will grab this. It will do something like this. It is const merge numbers is equal to, we can easily do something like numbers 1 dot concat numbers 2. Before ES6, we'll do something like this if you want to merge this. And we still have this thing here. If you go, we have 1, 2, 3, 4, 5, and 6 because we've merged this. And if we want to say, let's get the length, const length is equal to this without ES6, 1 dot length plus nums 2 dot length. So this is length, and then we say k is less than length. So in here we'll say merged arrays. This will be an empty array. So we'll come over here and then we'll say merged, okay, merged numbers. Then we'll push in all these numbers. We'll get a way to get the two of them and then push in. Or if you don't want to push, you can just do something like an array. We spread in the merged numbers. And then the next coming element, let's say nums 1 k, you add it at the end. But this is still spread. This is year 6. So we don't want to do this. We just push in at the end of the element, at the end of the array, actually. So that is before year 6, we could do something like that. But merge numbers, we have an array, and then we say nums 1, nums 2. We spread this. Something like this. So that is a combined array. So you can even do something like, okay, you just want to add 0 here. After spreading, you want to put something like 10, 11 before merging the last one. Come over here, run this. Okay, log merged numbers like this. Then you run this. You have 0, 1, 2, 3, 10, 11, 4, 5, 6. Then at the end, you can add 200, 2000 like this. You run this, you have this. So that is basically how this works. So for the spread way, initially before this actually is spread, but the rest in year 6, if you want to do something like, let me remove all these consoles so we have a clear. If you want to do something like, let's say we have a function sum that takes in 3 parameters, a, b, and c. Then what it does, it sums up return a plus b plus c. So we want to actually, in year 6, you can just come over here, say log sum, and then you spread a number of, let's say, the number of array. Let's say we have number of an array of numbers 1, 2, and 3. We have an array of numbers here. You just spread this array inside this sum. That's year 6. But before year 6, what you will have to do is you have to say, okay, const result is equal to sum dot apply null, and then we pass in numbers like this. So without doing this, it will not work. Without doing this, it will not work. So you come over here and you see log the result. Let's try this out. And then we have 6. 1 plus 2 plus 3 is 6. This is before year 6. But with year 6, you just come over here, and then you spread this. Do this, and you have your 6. So now we have year 6. And we are good to go. No, there's no need of doing the apply and call and all of that the old way. So we just do that. So we actually demonstrated the rest. We did something, demonstrated the rest operator, where we say destructuring arrays, we say const this is equal to numbers, and then we get 1, which is the first number, and we collect the rest of the numbers, and we say rest numbers like this. So if you come over here and say log rest numbers, you have your rest numbers here. So the rest numbers are 2 and 3 because we've destructured this one, and then we collected the rest of the numbers in this variable, which is rest numbers. Okay, so we also demonstrated it in objects, where we have an object of const user is equal to an object, and then the name is John. Age is 29, and state is, let's say, Lagos. So we can do something like, let's see, const this is equal to user, and we'll get the name, and then rest user, the rest of the user. We'll collect the remaining properties in this variable, and then we'll say log rest user. As you can see, what the rest operator is doing, instead of unpacking, it's packing it in this container here. So we'll log the container. Okay, rest user. What's happening? File name have already been declared. Okay, let's rename this to N. I don't know why. Then, so we have AH29 state Lagos. So we've destructured name and then collected the remaining properties in a single REST user variable, which we are logging it here. So that is basically the REST operator. That's how it works. Okay, so moving on. That's the essentially that's the basics of default parameters, REST, and spread operator. So now we can use them without misunderstanding them, or without having a doubt. We can use them without doubt. We now understand how they work under the hood and how they are used. But before ES6, you couldn't do that. Okay, so we have modules. Modules, we have import, export, and default. Okay, so before I continue, Janet, is it Moromoke Janet? Please, if you have any questions or you misunderstand anything, you can just raise your hand and I will allow you ask your questions. If any one of you have any questions at all, just raise your hand and I will allow you ask your questions. Or you can just excuse me and I will actually allow you ask your questions. So any questions at all? Okay, Moromoke, you can go ahead and ask.
Okay, good morning. It's actually on that last part because I think the understanding that I have is that whatever you declare is what you can use. If one thing is not declared, then it doesn't work. So when we now have that REST user, I begin to wonder where we are getting it from because it's user that we have declared. So what's the logic behind the user being transferred its data set to that REST user?
Okay, thank you for asking. So what is happening under the hood is this. What is happening under the hood is this. We have name, age, and state. So name, age, state, right? So we'll come over here and say const REST user is equal to age, state. Now log this to the console. Okay, I don't know why it's saying name is already declared. Name. Okay, we have name here of John. Let's see. Name here is user name. Okay. So now we have age and state. So what JavaScript is doing for us under the scene or under the hood or behind the scene is it's what we are doing here. We're actually declaring a constant. Okay, let's say JavaScript is actually a variable, not a constant. This is a variable. So what it's doing for us under the hood is this thing we are doing here. So if you do something like this, REST user, JavaScript, under the hood, JavaScript say, oh, this person wants to pack the rest of the variables into this, the rest of the properties into this variable. So JavaScript will create this variable under the hood, then pack the age and name inside of this object for us. Then we don't have to do this. Now we have this. Do you understand now?
Yes, yes. Thank
Yeah.
you.
So that's what's happening under the hood. So for modules, we have different types of module systems in JavaScript. We have the CJS, that is the common JS, and we have ESM, which is ES6 modules, which is what we'll be talking about. We have the import, export, and default export. So let's rush over this quickly. So we have modules JS, and in these modules, uh, let's see, we have util JS. Inside of this util, we can see const add is equal to A, B, and this will simply add A plus B like this. Then we can say export add. So without exporting this add, you cannot be able to access it in another file, in another module. So in JavaScript, modules are just files. So we have the arrow function module, we have the util JS module, where we can export things inside and then use them in another file. So here we are exporting the add. So instead of rewriting this add everywhere else we want to use it, we'll just simply import it from here and then use it. So inside of the module.js, we say import, that is the export statement, trying to make something reusable that you reuse it in other modules or other files. So now we can import add from, we have the autocomplete showing it's coming from util.js. So now we don't need to redeclare the function. What we need to do is say log add 2, 3. Now if you see node module JS, okay, modules, okay, log modules JS, we have 5 because we're exporting this function from this module and we are using it. So if instead of doing this, we can even say export const, and it's the same thing as saying export add. This is the same thing. So you are exporting it twice, and export const add is the same thing as saying export add. This is a named, it is also called a named export. This is not a default export, it's a named export. That's why when importing it, we're importing it as a named export, as an object. We can even do this, then rename it add numbers. Add numbers. We can come here, instead of saying add, now we get an error because we renamed this actually. So if you come over here and do this, we get an error. What is the error saying? Add, okay, as add numbers. We rename this. Now if you run this, we get an error saying add is not defined because we renamed this to add numbers. So here we have to do something like add numbers. Now it is no longer undefined and we get our 5. So what if we come over here and change this to export default, this export default, we change, now we cannot, this is not a named export, so we cannot do something like export default const add. We'll have to do something like this because this is why exporting everything in this file actually. So we say export default add like this. So if you come over here and we run this, we get an error. Add, the requested module util.js does not provide an export named add, because what we are doing is we are exporting everything. We can even come over here and do something like, instead of doing this, we can give this any name. We can say A, and coming over here, this is A. Now, if you run this, we have 5. We can change this to add because it's a default export and you can give it any name. Add. Do like this. So what this is doing is when you do something like import add from util.js and you say this is a default export, what JavaScript is doing is JavaScript will say, okay, the module system, read everything inside of this file. So after reading everything, read the code inside of this file. So after reading it, come over here, declare a variable of add and assign the code to it. Now, when you call the code and do this, what is the code in this file? It's just a function that add A and B. Then you come over here, assign the code to this file, and then execute it. So when you execute the code, it's just a function add 2 and 3. It will add 2 and 3 and give you 5. So now you cannot do anything like this is not a named export. So it will throw an error. So util.js, you can even do something like const sub is equal to A, B, return A minus B. That instead of doing export default add, you just export default add sub. So what you are doing now is you are exporting an object. This is an object, not just a named export. This is an object. Now, if you come over here in the module and you run this, you get an error. Add is not a function. Now, if you come over here, they say console.log add. Since it's not a function, you want to see what it is, then you log on the console. You have, it is an object with two functions. The first one is add and the second one is sub. So you can come over and say util, since it's the whole file, you could say util. And then here you say util, since it's an object, you are exporting it as an object, say util.add, pass 2, 3. And you do another one, util.sub, you pass 3, 2. If you log this to the console, you have 5 and 1 appropriately, because 2 plus 3 will give you 5 and 3 minus 2 will give you 1. Or if you don't want to do that, you can just come over here and just say add sub. Since you are importing it as an object, you just destructure these two. And instead of saying util add and util sub, do something like this. Add sub to request module provide export. Okay. Okay. So we're having that util, you see, const, sorry about that, add sub is equal to util. So, now we have 5 and 1. So this is an object. So after importing the object, you destructure add and sub from util, then you get your functions to actually execute. But if you don't want to write extra code, you just say util add and util sub. This must not be util. It can be anything. It can be math. Okay, we don't want to conflict it. Math. Then you come over here and say math add and math subtract. So you can just do math add. Come over here, log this to the console, and we have our 5. So that's basically it for modules. Working with 6 modules. And the reason why it's adding JS here to tell the tell Node.js, okay, what you are importing is a JavaScript file. But in TypeScript, you can do something like util.js, or you can just do something like util. But if you do this, JavaScript will throw an error here saying, did you mean to import util.js? Error, could not find module and all of that, because trying to say, okay, this is a JS module. So to know how to resolve it. So that's basically it for modules. So moving on, we have promises. Promises. Okay, so we have promises, and under promises, we will understand asynchronous handling in JavaScript. before talking about the promises actually. So the asynchronous problem, JavaScript is single-threaded, meaning it can only execute one operation at a time. However, many operations like network requests, file operations, and timers take time to complete. So if you're just running a single thread instead of multi-thread, you have to, if a file operation or a file write, if you want to read a content from, like read a file from a disk, you will have to, if it will take like 10 minutes, you have to wait for 10 minutes before any other thing will happen. So that's where promises comes in. Asynchronous programming and asynchronous handling in JS, in JavaScript, that's where it comes in. So if you want to do that without asynchronous programming in JavaScript, with just a single thread, that will block the thread for 10 minutes if you want to read a file from a disk, and the time that it will take to read that file is 10 minutes. It will block the thread for actually 10 minutes. And then you don't have to do anything. You'll just be there waiting for it. So JavaScript, first of all, used callbacks for this. So callbacks are just functions passed to other functions to be called when async operations complete. So it evolved to promises, which promises were introduced in ES6, ECMAScript 6, which is what we are discussing in ES6. So this is an object or objects representing eventual completion or failure of asynchronous operations. Then async await was introduced in ES 2017. This is no longer ES7, but ECMAScript 2017. ES6 is ECMAScript 2016, and not ES7, but we have 2017, ECMAScript 2017. So this is just a syntactic sugar over promises for cleaner async code. So let's first of all understand the promise mental model. So it's actually very it's a good thing to understand mental models over of certain concepts, so that when using them, you actually know what you're doing. So a promise, think of a promise as a receipt for an operation that we complete in the future. So when you run that operation, it will not complete at the moment, but in the future. So the receipt has three possible states: pending, fulfilled, and rejected. So pending, the operation is still in progress. Fulfilled, that is resolved. It is fulfilled, it is being resolved. The operation completed successfully. So if the promise is rejected, the operation failed. So promises have three states: pending, fulfilled, and rejected. So why do they matter actually? Why promises matter is because we actually want to avoid callback hell. That is deeply nested callbacks. We don't want to nest 3, 4, 5 callbacks inside other callbacks. So we have a callback, and then inside that callback, we have another one. The second callback inside of the first one, we have another callback. That would be hard to read, debug, and test. So that was the reason why promises were introduced in ES6. So 3 states of promises. We talked about pending, fulfilled, and rejected. So in creating promises, we use the promise constructor. This is a constructor, actually. It's like a function. It's a constructor function, but JavaScript implemented this under the hood for us, so we can just use it without having to do this every time we want to write a promise or every time we want to start a new project. So creating promises, we use the promise constructor with an executor function that takes resolve and reject parameters. Note the word executor function. So consuming promises, we use the then for success, the catch for errors, and finally for cleanup. Let me repeat again. We use the promise constructor with the executor function that takes resolve and reject as parameters. And in consuming promises, we use the then for success, catch for errors, and finally for cleanup. Then we have promise chaining. So then returns a new promise, allowing method chaining for sequential operations. Maybe you want to get the data first. So after getting it, if the data is available, you want to actually chain it. You want to process it again in another step. That is what chaining is. You chain method on the data to perform different operations. So we have promise method and patterns. So for static methods, we have all settled, race, resolved, and rejected. So promise.all, wait for all promises to resolve. Promise.all settled, wait for all promises to complete. That it's either it succeeds or fail. Promise or rest, resolve or reject with the first promise that settles. Whether the promise failed or it succeed, it will resolve with it, the first one that settles. So promise or resolve, create a resolved promise. And then create promise or rejected, create a rejected promise. So error handling in promises provides centralized error handling through the promise chain. So there's a promise chain. That is what we call the then, the catch, and finally. So the then is for the resolved parameter that was passed in the resolved parameter that was passed in the executor function. The catch is for the rejected parameter that was passed in the executor function. And then the finally is to run cleanups or do something, even if the promise fail or it succeeds. So we can do something like, let's quickly give an example of a promise. This is a basic promise. We can say const basic, or let's say basic promise is equal to new promise. So this is the syntax. Now, what will come inside of this promise constructor is an executor function. So we pass in an executor function like this. This is the syntax. So inside of this function, remember that it will take resolve and reject parameters. So what do we want to do inside the executor function? When you call a new promise, this function will be executed. So let's simulate a promise here by setting timeout. Let's say set timeout. And this, normally set timeout to take a callback and a timeout, which the timeout is just a second. And inside of this callback, what we do is we say const success is equal to math random. And then we say if it is greater than 0.5, then it's the function should resolve. So how we're going to do this? We'll say, okay, inside of this set timeout, we say if success resolve, let's say operation successful, like this. Let's add an exclamation mark. Else, if it's not if math random, the value is no greater than 0.5, we will actually reject it. It's a new error with operation fade, like this. So how do we use our promise? So we'll do something like basic promise. Then we say dot, then basic promise. Basic promise. Is it a basic promise? Dot then. And this then Remember, there's a resolve and a reject. So this resolved is what is being called, what is being returned in this then. So we have a callback function in the then, and inside then we have the result. We can basically say log result, or we can say log success result. And then we see dot catch, and inside of the catch we have error. But what the catch is returning is an error. And inside of this error, we see log the error on the console. Error, and then we see error like this. Okay, missing a comma, error. So finally here is just whether the promise fail or it succeeds. Say finally, pass in a function, callback function. You see log promise completed. Let's say promise completed, whether it's successful or it failed, like this. So let's go ahead and run node promises.js. So first of all, you notice that it took time. So if you increase this to 2, that is 2 seconds, it will take more time. So here we have success operation, success. Let's add a colon here. Success, operation successful. Then finally must be called because there was no error, because the math random was actually greater than 0.5. And if you want to see that, we can actually come over here and log success. So we have now it's C greater than 0.5 because it's true. Math random here is greater than 0.5. That we have true. Success, operation successful, promise completed. Finally must be called. So in here, if we want to change this and want to do other things with it, we can actually come over here and say return result dot to uppercase, because we know that result is actually a string. It's not an object, it's not an array, it's a string, because this is what we are resolving. If we resolve an object, what would we be expecting here would be an object. If we resolve a number, what we'll be expecting here would be a number. But we resolved a string, so we are expecting a string. So now we are returning result.to-uppercase. If you run this once more, now we have success, operation successful. So we actually wanted to see if anything is returned. So we've seen that result is returned. So we say dot then. The reason why we are adding another then is because we are returning this, we're returning something. We're actually, let's say, performing an operation on the result and then returning it. In here, we take another function and see, maybe u result, which means upper result because it is uppercase. And then we say log u result. Now we can go ahead and run this once more to wait for 2 seconds. And now we have error, operation failed, because now math random is less than 0.5. Let's run it once more. Operation failed again. Run it once more. Okay, so now it's successful. As you can see, the first then here return the result, success, operation successful. Then second then here, we are returning the result to uppercase. Then we are passing it to the next callback. But then we pass in a callback, we grab the uppercase result, and then we log it to have operation successful in capital letters. So this is basically how promises work. So you can do this, and you can perform asynchronous operations like fetching user data, doing other things. And you can even do something like cost result is equal to await basic promise. Is basic promise a function? Okay. Okay, basic promise is not a function. No, not that. Okay, you have to async. Let's say async function. Come over here and say resolve basic promise. So you're resolving the basic promise. The next thing you do is you take the basic promise, the promise, you put it in here, you resolve it, and then you can call await on it. But for now, we will not do that. This is just promise, it's not async await. If you have an async function, let's say we have an async function. This async function here, let's call it async add. And in this async add, what we are doing is we are taking in A, B, and then we set timeout. Let's grab this timeout over here. We'll grab this timeout, drop it in here, and then we'll wait for 2 seconds. So after the 2 seconds now, there is no resolve, reject, remove this. If success match random is greater than 0.5, we'll log success. Else we just throw a new error like this. That's after 2 seconds. So this is an asynchronous function. But note, under the hood, this is using promises. It's using a promise to do this. Then we can come over here and say const result is equal to await. And then we call async add. We pass in 2 and 3. Okay, or let's say if it's success, return 2 plus 3. Or return A plus B, like this. Else, we'll return B minus A, like this. So we can come in here, we'll pass in A and B. Now let's log result. Now if we run this function, it will wait for 2 seconds, undefined. Then we have true. Okay. Async. Okay. Result is equal to 0. You see, result is equal to A plus B, and result is equal to B minus A. Return result. Result before initialization. Let result. So now we have 0. And we have 0 true. Okay, 0. We'll have to wait. Okay, so this is wrong. Before the promise is done executing, we have 0 here, and 0 will be returned. So we have let's remove this set timeout. I don't want to go doing this. Remove the set timeout. We have success is this. Then okay, if success, let's just do a shorthand. Return success A plus B, else B minus A, like so. Then we'll call this this is not actually an asynchronous operation, but I'm just showcasing this. But this is an async, and if you remove the await, run this, as you can see, this is not resolved yet, because here success, it seems success, the match random value is less than 0.5, and that's the reason why it's returning B minus A. But it's showing you that this is a promise and it has not resolved yet. You are logging it, it has not resolved, and you are logging it. So we can even come over here. So if you add an await, it will first of all wait for this to resolve, and then you have your value of 1, and then in the next 2 seconds, this one here will execute. Okay, so briefly, that is promises, just the introduction of promise. So we have map and set. So for map and set, sorry to say this, but we'll be looking at this in our next class due to time. Look at map and set in our next class. So for today, we move to classes. We'll look at classes in depth and we'll try to understand classes actually. So due to time, that's the reason why we're skipping map and set, though there are ES6 features, but we'll look at them in our next class. So we earlier discussed classes, but we didn't go in depth. We just talked about, we introduced ES6 classes and how they're being used. So in this class, we will look at classes, class declaration, constructor, instance methods, static methods, inheritance, disbinding, polymorphism, composition, introduction to dependency, injection. And our objectives for today is to master class syntax, inheritance, and polymorphism, understand the this key binding and static versus instance methods, learn composition over inheritance and dependency injection. Okay, so moving on. First, we have introduction. We introduce classes. So what is a class? And then we learn how to declare a class. So as we earlier mentioned, a blueprint, a class is actually a blueprint for creating objects with shared properties and methods. So it's just a syntactic sugar over JavaScript prototype-based inheritance. So if you want to create a class, so if you want to create a class, we first start with the class keyword, class, and then we have, let's say this is a person class. So this is a class actually. You've created a class, but this one here is useless because we are not using it to do anything. So you can create a class, add a constructor, and then add method. You can add a method of add like this. So if you want your class to be useful, you will have a constructor first. And don't worry about constructors, we would discuss that. We add a constructor and you add other methods because the constructor is the first method you will add because this is a special method right here. So this is a class signature. Basically, it's nothing much, just this class person. So this is the name of the class. This may be anything, car, person, house, or anything. It can be storage or anything. So this is the signature. The constructor, not a must that a class will have a constructor. You can actually remove this. Then you have a method. And we have instant method and static method. Okay, so now that we know what a class is and how to declare a class, we move on to constructor. So what is a class constructor? So the purpose of a class constructor is just this is a special method called when an object is instantiated. It is actually used to initialize object properties. So when you call an object, let's say we have our person class right here. This is our person class. So we add a constructor. We have a constructor that takes a name and age. Now we say this name is equal to name. This age is equal to age. So now that we have this and we have a constructor, if you come over here, you instantiate an object with this class. Let's say const John is equal to new person. You pass in a name of John and age of 29. Now let's log John to the console. We have name John and age 29. So this is John name. What do we have here? We have the name is John. Now, if you create another person of Kent and you pass in Kent as a name and age of 59, if you log that person, you will see that the name will be Kent and the age will be 29. So the construct, that is the reason why it is said it is a special method called when an object is instantiated. It is not called when you create a class. No, it is when you instantiate an object that this constructor is called. It will call this constructor and then bind the name you pass in as argument to this. Bind the name and the age to this object you create, not the class. This binding is happening when you instantiate an object, and this is when it will call this and then bind this name and this age to this object you are creating from this class, this blueprint here. So the second option, the second point here is used to initialize object properties. So it will initialize it. Even though you are changing, even if you want to change this later, first the name here will be John and the age will be 29. So it will initialize the name here to John and age to 29, even if you want to change it later. And this here is public because if you want to declare private properties, you come here and we say name is equal to John. This is yes 2022, ECMAScript 2022, and you see age 29. Now, if you come over here, let me just comment this out. And you do something like this. Let's log this to the console. Let's just log John instead of John name. John, log this. Then you have a person of empty object. This is an empty object here. Console log John. John doesn't have anything inside. So this is private. You can only access it in. Okay, let's do something like this. This dot name is equal to name and this dot age is equal to age. Now come over here, log this once more. We have empty because this was name equal to name age. Okay, because we're passing in John 29. So let's log this once more. And we have this because these now are private properties. These are private. You cannot access it outside of this class. But then you can do something like get details like this. you say return this dot age okay, let's say this name is year 6. So let's just utilize year 6 instead of wasting our time here. Okay, this name John is this age. John is 29. So if you come over here and say John get details, this is a method, so we'll call it, then we'll run this. So see, John is 29. But if you do something like, okay, let's say John get John.name, you will get an error. Undefined. Okay, it's actually undefined because it is not defined. It's not an error. Okay, so these are private. If you want this method to be private, then you add this. And now if you go ahead and do something like this, you get an error. John get details is not a function. It's not even because you cannot recognize it. This is a private method. The reason why it's private because you can only access it in this class. So if you want to make it, let's say public details, then you say okay, return this get details like this. And now you can see you can get public details. Now you have John is 29. You have John name is undefined because you cannot access name. So we now know about private properties and public properties. So you know we are not used to object-oriented programming, but it's very, very necessary to have public properties and methods and private properties and methods. But I believe the more we go into object-oriented programming, we will understand the importance of having private and public properties and public and private properties and method. So we've gone too far. We're just talking about the constructor, and we've learned about the constructor and its syntax. So moving on, we have instance methods. So instance method are functions defined inside a class that operate on class instances. These are just functions defined inside of a class to operate on class instances, nothing more. I earlier discussed about this. So this is instance methods. These are instance method. We have static method and instance method. So that's the reason why we're first of all calling this. And we don't even have to do this here. We can just copy this, bring it over here. Okay, so do something like this. Something like this. Okay, what's happening? Listen, John, expected 1, 2, expected. Oh. Okay, so I am doing it the wrong way. It has to be at not the front, at the back. Dot public details like this. Like this. So John is 29. John is 29, but you cannot access this method outside of this class. These ones here, these are private. You can only manipulate them inside of this class, but anything outside, now we're trying to get these details outside. The only thing we can get is the one we're giving access to, and the only details we're giving access to, the only methods and properties we're giving access to is the public details, nothing else. So we can only access the public details outside of this class. So that is the reason why we're getting it here. And these are instances. These are instance methods, not static methods. And we'll look at static method in a bit. Okay, so Now we know what instance method are. We have to call the class with a new keyword. And then that object that is created from that class, the object that is being instantiated from that class, is the one that we have this method that we can access, because they are instant method, because we can only access them when this is instantiated, when we create an object from this class. So now we create the join object from this class and we can access the public details. Without that, we cannot access these public details. And even if we can access the public details, the instances, the instance methods that are private, we can still not access them because they're only manipulated and accessible inside of the class, not outside. Okay, so now that we understand instance methods, let's move to static methods. And I will have to remind all of us as we are moving, if you have any questions, just raise your hand and we'll get it resolved. We'll get to understand ourselves. Okay, so now we have static methods. So these are methods called on the class itself, not on instances. It's basically useful for utility functions. So let's say we have, let's emulate the math, say class math, and inside of this, I will say static. The static here we have, I think the math has an absolute method. It is called, is it abs, something like this, absolute. You pass in a, we pass in any parameter. You see, if the parameter is less than, if it's less than 0, they will say return -1 multiplied by that that parameter. Else, then we'll return the parameter itself. So absolute means we want to make negative values positive, and if they're already positive, they're already positive. So we don't want to know what sign they are carrying. If they're negative, they should be positive, and if they are positive, they're already positive. But we'll apply defensive programming. We'll first of all check if there is no value. We throw new error. Let's say empty value argument. Let's copy it and bring it down here. If type of the argument or the parameter I want to check is not a string, sorry, it's not a number, then what we throw new error, value must be of type number, like this. Value must be of type number, like this. So if there's no value, if the type is not of number, then we do something like this. So now we can use our math utility function. We can come here and say math.absolute. Then we pass in yo. Okay, so let's log this actually. Come over here, run this, and then we have this error. Value must be of type number, because what we're passing in is a string. Come over here, then we pass nothing. Then we run this, we get another error, empty value argument. Then if we pass in -20, come over here, then we have 20. If we pass in 20, see the same thing, we have our 20. So basically, this is a static method, and look at how we're calling it, math.absolute. It's just like a utility function. We don't have to instantiate initiate this before grabbing this from the object we are creating from this class. We just call it on the class itself. And the reason why I am adding an underscore to this math is basically how to, this is basically how to write, is it 2 or 1 underscore? Basically, we already have a math, okay, let me remove this. Remove this, call this. So we have 20 here. But how are we sure that the method we are using is not the math in the one JavaScript has, and not the inbuilt math operator, and not the one we've implemented? Can you see that? Because there's an absolute method and on the inbuilt one. So if you come over here and pass minus 20, this is actually the inbuilt one, not the one we've declared, not this one. So for us to use this one, we'll have to do something like this, make it different from the one we have over here. That is, if you are programming and you need to actually rebuild inbuilt functions to actually know what's happening under the hood, or recreate them by yourself, this is how you go about it, so that it will be clear to you that, okay, this is the one I'm creating and this is the one JavaScript has under the hood. It's using the input one JavaScript has for us. So this is basically a static method. Okay, now that we understand instance method and static methods, we'll move over to inheritance. So we have the extend keyword and the super keyword in inheritance. So the extend keyword allow a class to inherit from another class, and the super keyword calls the parent class constructor or method. Okay, you know, let me just repeat this so you get it very clear. Allow the extend keyword allows a class to inherit from another class. Inherit keyword, it will allow that class to inherit from the super class or the base class. So the one inheriting from that is the subclass. So it will inherit methods and properties from the super class, that is the base class. And then the super keyword calls the parent class constructor or method. It's called the parent class to get its constructor or method. So let's, for example, let's say we have let's say we have a class animal here, and this animal class has a constructor that takes in a name as a parameter, and this, let's bind this to bind the name. This name is equal to name. Then we add a method to this instance method, the static one, say speak. So the animal should speak. Then we say log, let's say this name makes noise like this. These animals make noise, but which animal? Because this is a blueprint. It's when we create an object out of this class that we know the animal that is making noise. That is the reason why it's called an instance class. This will be called on that instance we create from this class. So if you come over here, we want to inherit the name from this super class. So we can use this super class to actually create other classes like dog, cat, horse, cow, and the rest. So we can create a subclass of dog. And each dog subclass, we say extend animal class. And this animal class has a constructor that takes in name and breed. So now we want to inherit the name from the super class. So we say super name. And what we say? We say this breed is equal to breed. Okay, so before I continue, let me tell you what's happening. We are not entirely writing a new class. we had a first class that is generic, that other classes can be created from. But then what we want to do is we want to have a class that has a breed property as well. So we created a new one, extended this class that we inherited from this one, then added a new property to it. This is not an entirely new class. This we're extending from this one. This one only has the name property, but we want to add the breed. So that's why we're calling this one, extending the name and then adding only what we are supposed to, what we want to add. We don't want to create a new one. So this we're just inheriting from this animal class. So now we can go ahead and speak. We can go ahead and add our method of speak. And the speak method here, what it will do is we say log say this name barks. The dog, dog's bark. So we don't know which animal here, but it makes noise. But now we're specific because this is the dog class and we're saying the dog barks. So if you come over here, say const dog is equal to new dog. And then we pass in a name of, let's say Rex. We pass in breed of a cookie. Let's pass in a breed of a cookie. Then we say, we call dog speak. Breed, not breed, speak method. And if we go ahead and log this to the console, we have Rex barks. So as you can see, we're having two identical methods in animal and dog. But then when we call the dog, this method is being invoked. So we'll look at that in a minute. So this is basically inheritance. This is inheriting from the superclass, but then the name, we are not binding it here. We are inheriting the name from the superclass. And then we're adding the method. The only method we want to add is breed. That is what is missing in this class, this breed method. And we also want to modify the speak because it says the animal speaks, but we want to say it barks. And then we can say, and the breed is this breed. So if you come over here, do this, you have Rex barks and the breed is a cookie. That's cool. So we've inherited the animal class and we've added another method and property to it. So that is basically inheritance. So now we move to the this binding. So for this is not a constructor function. We're dealing with ES6 classes that has like syntactic sugar to constructor functions. But what this keyword does here is in the constructor function, it binds the parameters being accepted in the constructor to the object being created. Let's say the instantiated object. When we instantiate when we create new objects from classes, this keyword here refers to that object we are creating, not the class itself. In constructors, this keyword here, refers to the dog, not the class here. This keyword refers to the dog. That's the reason why we will pass in Rex as an argument and a cookie. This will bind breed to the dog and not the class. It will bind breed to this dog. That is, if you create another dog here and we pass in another name, it will bind the name to that new object created, not the class. If you are binding this to the class, and anytime you create a new object, the name of the dog will be Rex. But because this is binding the name and the breed to the objects being created. That's the reason why each object created from this class, we have a different name and a different breed. And we also talked about the this binding, which it can affect context in callbacks. We demonstrated that in constructor functions. That's prototyper inheritance, which we use the this to bind all of that. And so I guess we'll skip over that for now because we demonstrated that, but we've not demonstrated it in classes. Due to time, if we have time after we're done with this class, we'll come back and quickly demonstrate this binding with callbacks and how it can be used to resolve the loose context in callbacks. How we can use it to resolve that. But right now, the next on the list is polymorphism. So polymorphism, this is a term in object-oriented programming, but we're not going to be general. We're not going to generalize this to object-oriented programming. What we do is we just tailor it to classes. So in classes, polymorphism is just the ability of different classes to respond to the same method in their own way. Okay, so we don't even need to rewrite this to demonstrate. Let's come back to our, can you see that we have speak and we have speak here? These are the same methods. Why is this class inheriting from this one? This one already have a speak, and the speak is declared in this dog here, and it still works different as this one. So that is basically polymorphism. They are working in different ways because the class we are creating this object from is the dog and not the animal. If we change it to the animal, and we'll say dog speak. And now if you do this, we have Rex makes noise. He doesn't bark anymore. Maybe Rex has issues. Rex is going through a lot. He doesn't bark. He just make noise. Wee, 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 and it's done. Okay, so now we move over to, let's just bring back the dog. And if you say dog speak, now they've treated Rex, giving Rex food, and Rex is strong as before, and now Rex can bark. Rex barks, and the breed is a cookie. Normally, Rex was given American food, and maybe it's changed to something, another breed. But now that Rex received treatment and is back to a cookie breed, Rex can bark. Okay, so this is sweet. This is basically polymorphism in action. So that one is very simple. That's I said we shouldn't generalize it to object-oriented programming because that would be, if I want to generalize this, it would take us a whole class to actually explain and then with examples. So we don't want to generalize, but you can go extend your research and make sure you understand deeply what polymorphism is, the use cases, and how important it is in object-oriented programming. So moving on, we have composition. So what is composition? So this is actually another term in object-oriented programming, but we tailor it to JavaScript classes. So when building complex objects, you want to combine simpler ones to make up that complex object. You don't want to always inherit and then add methods. Maybe sometimes you just want to combine simple classes or simple objects to make up the complex ones. Instead of inheritance, you use composition. So let's say we want to use composition instead of inheritance. How do we do that? Okay, so basically we have, let's say we have class of engine. This engine, an engine must start and stop. Okay, let's say start. It has a method of start. And in here, we say log engine starts like this. So we have another class of car. And this car has a constructor. It takes a constructor, this car class. This constructor takes in nothing, no parameters. But in the constructor body, we say this, the car engine is equal to new engine. This is the engine class we are creating over here. So this is a generic engine. So you want to change your car engine, you just bring this engine in, remove the old engine and put in the new engine. Okay, so now that we have this, we can add a start method in our car. So this method now, you see, this, understand the difference between composition and polymorphism. So here we say this engine start. Then we can log car started. Now we come over here, see, const my car is equal to new car. We will see my car start. We want to start our car and travel to somewhere else. So if you see node intro.js, we have, okay, so Rex should stop backing. We want to start a car. Rex should just rest for now. Rex, rest. Okay, so can just come over here, clear our console, log this. You have engine starts, car started. So let's go over this once more. This is composition. So we have an engine here that we can plug into any car and start it. So we have a constructor. This constructor takes no parameters, but we are binding an engine to this constructor. So which engine are we binding to this constructor? It's as if we are binding a new engine and then plugging into this car. So what does this engine do? It starts a car. It actually starts a car. So the engine actually starts a car. Now we come over here, say this engine is equal to new engine, this engine over here. So we want to start our car, this engine starts. You know, this engine now is this one, but this one has a method of start. So that is the method we are using here. Start, this one here. It's coming from this engine. So if you want to start a car, now we are starting this car with this start. This is a key. We put in a key, we turn on the car, and then the car will ignite the engine. So the engine now we call the method of start, and it will start. So now the car will tell us that the engine has started. So that is what is happening here. This is basically composition in its simplest form. Wow, this is great. And this is actually sweet, isn't it? It is. Okay, so moving on. This is just introduction because you need to understand some of these things. We've understood composition in its simplest form, but due to time, you can actually extend your research and get to understand it more better. Moving forward, we have introduction to dependency injection. And we are going in depth in this one. And in this class, we'll just understand dependency injection. We'll just introduce it. But in our next class, we'll go in depth because in case you don't know, in this bootcamp, we are using Nest.js as our framework to build server-side applications. So Nest.js heavily relies on dependency injection. So we have to understand it in depth in order to understand how Nest.js actually work under the hood. So we'll introduce it today, but in our next class, we'll go in depth. Okay. So essentially, dependency injection is basically providing dependencies from outside rather than hard coding them inside a class. You provide them outside rather than hard coding them inside a class. So this is actually different from it's different from composition. And now that we've understood that it's providing dependencies from outside rather than hard coding them inside the class, let's take a look at an example that differentiates this from composition. So let's say we have class of database, and this database class takes a method of save, and this save it takes in data. As you can see, this does not have a constructor. This class doesn't have any constructor. So now we see we log into the console, saving data to database. So this is our database actually, and it has a method of save. We can actually use our database anywhere, and we call this save data to save data in this database. So we have a user service class. Let's say we have a user service here. And in this user service takes a constructor. It has a constructor that takes in a database, because this user service deals with data and you have to save data to the database. And then we say this database is equal to database actually is equal to database. Now we want to be able to create a user in this user service. Say create user. This takes in a name, and in this we say this database create. No, it's not create, it's save. Yeah, save. This database save name. So but the database we are passing here is coming from the constructor. How then it's having the save method? Okay, so the reason why it's having a save method is this. Say const db is equal to new database, like this. They will call our user service. We say const user service is equal to new user service. So we pass in the db. Now we can say user service create user. Then we pass in John. Woo! So this is dependency injection. Can we say the user service depends on the database? Yes. So what are the user service dependencies? The database, because it depends on the database to function. Without the database, you cannot save data to anywhere. That is why it's called dependency injection. We're injecting the database in the user service. Now let's come over here, clear this. Oh, this car we have to stop for now. We want to start building applications to service our car. So it should just stop starting. So we can build a database that saves user data. Okay, so we have saving John to database. Whoa, is this not sweet? This is actually sweet. Now we have a database, class of database that saves data. And then what we are doing here is this, in a real app, this would be like saving data to an SQL database, SQLite or MongoDB or anyone. So the user service is a constructor of a database, and this database is equal to database, but it doesn't know what the database is. That is one sweet thing about dependency injection. This here doesn't know what this database is. But then in TypeScript, you have to provide types to tell it what the database will look like. So create user here takes the database, call the save method on the database and saves the user. Can you see this? This is actually sweet. Now we have the save method on the database. This doesn't even know what the database look like. But since we know that the database has a save method, we just call it here. Bind it to the user service, call it here and save data. Now, when we come over here, we just instantiate, create an object from this database. This one that has this method of save, pass it to the user service, and then call create user on the user service to create John. And this works perfectly. Wow, this is sweet. This is dependency injection. And the name dependency injection simply means the user service depends on the database to function. It cannot create a user without the database, so it depends on the database to create a user. And what we are doing here, we are injecting the database in the user service. And since it's a dependency that this user service depends on, that is what is called dependency injection. The database here is a dependency, and we are injecting it in the user service. This is what is called dependency injection, nothing fancy. So this is just the introduction. And in our next class, we'll take a look at how this works in details and all of that. So I guess we've come to the end of today's class. And if you have any questions, I am here because we still have about a couple of minutes, if not 7. We're here and we can discuss and try to answer these questions. So if there's anything at all you don't understand, anything at all in our previous classes, in this class at all that we've discussed and you don't understand, you can just bring it up so we can discuss. Yeah, Ngozi, go ahead.
Okay, so when we are talking about a factory function now, is that class an example of that factory? Is an example of factory function?
Yes.
That's the question.
Yeah, when I introduced ES6 classes, I said it's a syntactic sugar to constructor functions. So instead of doing something like constructor function binding and then doing the prototype.add prototype, doing polluting the whole system, we just call our class clean. JavaScript tried to add this class to make it support object-oriented programming and to work like Java and C++, all these are object-oriented programming languages. Though it is JavaScript is not 100% object-oriented, it tried to add this to make it look like it is object-oriented. So before ES6, we have to use constructor functions, but then they introduced classes. So behind the scene, these classes are actually creating constructor functions for us and then initializing this. And if we call extend, it will call this and then add that's called the prototype of the superclass, add methods to it using the subclass. So basically, this is the same thing as constructor function. But if you don't want to waste your time and write modern JavaScript code, you just use classes and then be concise instead of trying to confuse yourself with constructor functions. So it's the same thing as constructor function with added sugar.
Okay, thank you.
Yeah. So any other questions? Anything you don't understand at all that we've discussed and you want to be clarified about? Okay, so in absence of any questions, we will call it a day. This has been a wonderful class. Thank you all for attending and paying attention. See you all in our next class.